Now let's do it the Hamiltonian way. Are we ready? Okay, good. Ooh, this is exciting. This is gonna be fun. Take out your steps. Make sure I follow those steps. Hamiltonian way. Okay, what's step number 1, people?
Form the Lagrangian.
Form the Lagrangian. And for this case, the Lagrangian will be, okay, I'm gonna write this actually. I want you to write the steps down as I am writing them. Do not take shortcuts. Trust me, I have made many mistakes doing these problems, and I guarantee you, you will too. Okay, so follow these steps very precisely. Okay, step 1, form the Lagrangian, which was t minus v, which is 1/2 mx dot squared plus y dot squared plus z dot squared minus mgz. So I'm gonna move this up. So this is the only thing we see now. Step number 2. Generalized, wait, hold on. Generalized momenta for all coordinates. What are our all coordinates? X, Y, and Z. That means how many equations should you have now? 3. Good. And it should be Px equals partial L over partial X. Py equals partial L over partial Y. Dots. Don't forget the dots. And Pz equals partial L over partial Z dot. That's how you find generalized momenta. And I also gave you an equation for generalized momenta. What did that look like?
Partial L over partial Q dot.
P?
Yeah, P equals partial L over partial Q dot.
Q dot. Is that what you have?
Yes.
In terms of your coordinates? Yeah. So be very careful when you do this. So there should be 3 of them because you have 3 coordinates. Right. Now, what is going to be the results for partial L over partial X dot? You have your Lagrangian written at the top. What should this be? What are you differentiating the Lagrangian over? My dot. Mz dot. Stare at it. Make very, very sure that you know what we're doing.
Just X dot and X dot squared to get.
That's not true. That's not true. This is the only one that's true. So it'll be just partial over partial X dot of 1/2 mx dot squared. So you're differentiating over dx. 1/2 m is a common. You'll have partial over partial x dot of x dot squared, which is 1/2 m 2x dot, right? So this 2 gets canceled and you will get mx dot. Okay. Okay, number 3. What's step number 3, guys? Rewrite values. Okay, what does that mean? Rewrite values for Q dot, correct? Q was our coordinate. So that means I am looking for X dot. Is my X dot Px over M? What would it be here? Step number 4. What does step number 4 say?
Write the Hamiltonian terms of momentum Pi.
Okay, write the Hamiltonian in this form. Sigma Pi Qi dot minus L. That's what we want. What does a sigma imply? What is I in this case? I is always over the number of coordinates you have. Okay, so this means I have to rewrite this again. So it will become H equals Px x dot. Is that the first one from here? Yes? And now I have to sum over the other ones. So what will be my next one? What will be my third one? Pz z dot. Is that the first term? that represents this part.
Yeah.
Got it? And now I have to subtract the what? The Lagrangian. So I will write my Lagrangian again here.
So it had to be in terms of QI and P dot I.
Excellent point. Is this in terms of P and Qs? Okay, so something has to happen. And that's what we're going to do now. I have to replace these here. What will we be left with? Plus py squared over m plus pz squared over m minus, can I write this as 1/2 px squared over m plus py squared over m plus pz squared over m. I am going to change this plus sign to a minus sign and this to a plus sign. Can I rewrite this as 1/2 m px squared plus py squared plus pz squared plus m that? These two do result in that, right? There's a 1 with first term and there's a 1/2 with the other term. So it's 1 minus a 1/2 gives you a 1/2. Now, you should have a Hamiltonian in terms of P's and Q's only. Do you have all of your H in terms of P's and Q's?
Yeah.
So that is number 5. Now, what is step number 6? Which were Hamiltonian's canonical equations? Which were what? Somebody read them out to me.
We got partial H over partial PI
Oh, sorry. Partial H over partial PI.
is equal to Q dot.
Okay, and what's the second one?
And the second one is partial HUI equals negative P dot I.
Okay, so how many of these should we have? 3, right? So for each of them, we should have 3. So 6 equations in total. So along the x-axis, along the y-axis, and along the z-axis, this will be partial h over partial px equals x dot. This will be partial h over partial py equals y dot. And this will be partial h over partial pz equals z dot. Okay, what's the answer for this one? Partial h over partial px. Is this going to be py over m equals y dot? Is this going to be pz over m equals z dot? So far, so good? This is going to be partial h over partial x equals minus x dot. Partial h over partial y equals minus y dot. Partial h over partial z equals minus z dot. If I do this differentiation, do I get a 0 equals partial h over partial x? Do I get a partial h over partial y as a 0? And do I get a partial h over partial z as a minus mg? Oh, wait, hold on. I messed up. This should be a p. Nobody corrected me. Okay, px, py, pz. Now we're okay, right? I forgot this was a p. Can I plug them into these equations above here? So will I get minus px dot? And 0 equals minus py dot. And will I get minus mg equals minus pz dot?
So we said mg is positive.
Oh, it is. You are right. I messed that up. Thank you for that catch. What is PZ dot? Think of Newton's laws. Isn't force dP over dt?
Yeah.
So can I write this as minus mg? And then f of y equals 0. And f of x equals 0. Aren't these the same expressions as we had here and here? Woohoo! Yes, sir.
A quick thing for notation, if we go back, use for a negative MP equals F, use a Y instead of a Z.
Oh, yes. That, yes, that should be a Z. Good catch, people. Good job.